26 and 27 will lump together. What are the critical values for a two-tailed t-test when alpha is 0.02 and n is 19? So this is a two-tailed t-test, right? T-test. Let's go to the table. See, for the two-tailed t-test, we can get our alpha, right? What's our alpha again? 0.02, right? But we need more information. We've got this df thing here, this df. We're not getting z values because this is a t-test. So here's what df is. df stands for degrees of freedom. And that you use that when you're finding a t-test. I explained in the lectures what they are, I believe. But degrees of freedom is just n minus 1. So in this case, the df is going to be 19 minus 1, which is 18. So 0.02, two-tailed, 18 degrees of freedom. Two-tailed, 0.02, 18 degrees of freedom. So here's 18 going straight across here. 0.02, two-tailed, 2.552. So this is two-tailed. So t equals negative 2.552 and positive 2.552. Also written as plus or minus 2.552. Those are your critical values for your two-tailed t-test. A recent study of business travelers claims they spend an average of $41 per meals. That's a recent study. As a test of this claim, a random sampling of 16 business travelers found that they spend an average of $45 per day. That's the average of the sample. And the standard deviation of the sample is $3.65. For the critical values, alpha is 0.05, two-tails. Now, we don't know the population standard deviation, so this is another example of a t-test. And it says a two-tailed t-test. So the degrees of freedom here would be 16 minus 1, which is 15. 0.05, two-tails, 15 degrees of freedom. 0.05, two-tails, 15 degrees of freedom. 0.05, two-tails, 15 degrees of freedom, 2.131. Two-tailed, so negative 2.131, positive 2.131. So plus or minus 2.131. Critical values.